Next, we're asked to find a 95% confidence interval for the average amount of overcharges paid by the homeowners who did not get the reduced rate. So what do we do for that? Well, we can go back up here and we can say they took a sample of 300 loan refinances. 165 were overcharged, and of the ones that were overcharged, the average overcharge was $350, and the SD was $250. So remember that when we are computing a confidence interval for the average, what value stays exactly at the center? The average we observe. So the confidence interval is going to be 350 plus or minus something, and we're going to talk about what that something is. So the SD, the observed SD, is 250. But what do I need for this? I need the SE. So I have 165 were overcharged. Now don't use 300 here, because it said only 165 were overcharged. 300 were not overcharged. So this is the number of people overcharged. Because the others had an overcharge of 0, they were not overcharged. This says for the average amount of overcharges paid by those who did not get the reduced rate. So remember, this is our N in this case. We do not use 300. So how do we compute the SE? Well, the SE then is just SE of the average is 250, that's the SD, divided by the square root of 165, because this is the number of people in our sample who didn't get a reduced rate. And that is about 19.46. 19.46. So remember, if we're doing a 95% confidence interval, 95% means we use 2 SEs, means 2 SEs away from average, the observed average, the sample average. From the sample average. So this 350 plus or minus, what is it plus or minus? The plus or minus is 2 times the SE of the average. So the confidence interval, 95% CI, is 350 plus or minus 2 times 19.46, and that is about 311.08 to 388.92. That is our 95% confidence interval. So this guy in the middle, this is our SE. We go out 2 SEs, that's 95%. Next part of the question is just a true or false. It says the probability histogram for the percentage of eligible loans in the sample that were overcharged is approximately normal. For the percentage of loans that were overcharged. Now remember, we can think of the percentage as coming from a 0-1 box, right? Because the percentage is the sum divided by 300. This sum is sums from a 0-1 box, which means, by our central limit theorem, that that's approximately normal. We know sums from a 0-1 box from a 0-1 box look normal. Normal. Oh, ran out of space. Look normal if we take enough, if n is big, so if we sum and if we add up enough of them. If we add up enough things in the sum. If we add up enough. So this is true. I'll put a big red true. Now we ask the empirical histogram for the amount of overcharges is likely to be approximately bell-shaped, right? That's another word for normal. Well, this guy we're going to put a big fat red F. Why are we doing that? Because we were told that the average overcharge is 350 and the SD of the overcharge is 250. So what does that mean? That 0, in this case, is 1.4 SDs to the left. Right? That's no good, because we're cutting it off. A normal curve would look like this. Oh, but we're chopping it off around here. So it can't look like a normal curve. Even if it had this same shape, we'd be chopping off too much of the tail. It probably looks more like this, not like a normal curve, right? You need, general rule of thumb is, if an allowable value is, if you move 2 SDs to the left and to the right and you're still in an allowable value, then you're fine. But here, 0 is the lowest allowable value. It's the lowest that the overcharge could be, but that's less than 2 SDs away from the average. So we say it is unlikely that it looks in any way like a bell curve. So that's the end of this problem.